Hi everyone, thanks for your time today. I hope you've been enjoying the workshop presentation so far. I know I have. My name is Bronson McPherson. I'm the Director of Engineering at Manly Hydraulics Laboratory. Today, I'm going to show you some of the work that we've been doing developing real-time modelling of intermittent estuaries, or as we like to call them, ICOLLs. I'd like to acknowledge Galen and Matt, who've been working on these projects with me. I will first tell you about the MHL Flood and Coastal Intelligence Tools, or MHLFIT for short. I will then take you through a case study of some work we did on the Central Coast developing an MHLFIT tool for their lagoons, and then a bit about what we are doing in the future. MHL's Flood and Coastal Intelligence Tool is a suite of applications and services that provide real-time data, visualization, and predictive decision support tools to aid water management, including intermittent estuaries. It's designed around a framework that allows rapid development and deployment of customized tools with a web interface. The system is built using cloud architecture and utilizes dynamic load balancing and failover redundancy using backup servers in multiple regions. It's supported by a high availability database with more than 1,000 sites across New South Wales and over 50,000 station years of QA'd environmental data with records back to the 1980s. The MHLFIT provides real-time decision support through real-time visualization via map interface, interactive plotting of data, and model results. The ability to undertake real-time scenario modeling. It can show historical entrance behaviour through harmonic analysis and real-time IFDs. I will now show you a case study of the Central Coast Lagoons that we've developed for Terrigal, Avoca, Wamberal, and Cochrane. We are very lucky that there is a lot of good information available for the Central Coast via the former Gosford and Wyong Council's monitoring, which has now been consolidated into the Central Coast Council. The first thing we do when we develop an MHLFIT system is the hydrological model setup. Often we set up this using local flood study, which in this case we had just completed for each of the lagoons. We use standard routing techniques and it runs on a custom Linux compiled version of WBNM, an Australian-based hydrological model. We use the initial and continuing loss method, but we're investigating the use of artificial intelligence. The initial losses are calculated using antecedent loss estimates from the previous 10 days. The next thing we look at is the entrance model setup. This is one of the key aspects of real-time modelling when dealing with lagoon modelling. Here we see the gradual progression of Wamberal entrance. As you can see, the behaviour is fairly complex, but we need to simplify it for use in a real-time model. It's important to make things as simple as possible, but not simpler. I like that quote from Einstein. Back in the 90s, there was a lot of fieldwork and analysis undertaken around the northern beaches and the Central Coast. Gordon found some consistent behaviour regarding entrance opening for a number of lagoons, including those around the Central Coast. It describes the initiation stage, the weir hydraulic jump stage, and then the river flow stage. For our real-time prediction, the first two stages are critical for lagoon entrances such as those on the Central Coast. We are lucky to have a plethora of data for these lagoons, and we're able to develop automated techniques to analyse the data. Some of the information was water level data to assess typical opening durations and widths. The entrance model is based on the statistical analysis of the existing water level, tide, wave, and rainfall data. It is also important to understand the entrance management policy, have a good local understanding on the entrances, and access to historical information, including photographs, burn height measurements, manual openings, and entrance widths. Here are some of the calibration validation results for Wamberal. Using the catchment rainfall with a hydrological model and knowledge of the height at which the berm will start to overtop allows for a reasonable calibration of the key parameters. Modelling it in real time is usually a bit more difficult. So what are the data inputs we use? Catchment rainfall, water levels in the lagoons and the surrounding areas, the entrance condition. In the case of the Central Coast lagoons, it's mainly whether they are open or closed. However, with some larger systems where there are more nuances with regards to how open the entrance is, such as Narrabeen Lakes and Tuggerah Lakes, a more detailed assessment of how the open entrance is made in real time using recent data. Now we come to the forecast data. There is quite a bit of this and is sourced from a number of places. We use rainfall predictions from the Bureau of Meteorology from the Australian Digital Forecast Database. We use astronomical tide forecasts that we've developed from previous year of data. We access ocean level forecasts from the Bureau of Meteorology as well. These forecasts will often predict anomalies caused by low pressure systems and coastally trapped waves. We utilise the New South Wales nearshore wave forecast to provide input into the modelling. Wave pumping impact has been assessed using historical data analysis in the model development. The berm heights and entrance opening closing behaviour are also utilised. Here we see the results of some of the real-time modelling for Wamberal and Terrigal. These results are shown during an event with actual tides and rainfall, but everything else using forecast inputs. Of course, during an event, we have to use predicted tides and rainfall that make it a bit more difficult to predict. We're currently finalising an MHLFIT tool for Tuggerah Lakes, which has been another challenge. The MHLFIT tools have a dashboard to present key information. This allows you to easily look at all the information in one place. Scenario modelling allows one to look at the what-ifs. If the rain is a bit higher than expected, the ocean anomaly is larger, or the waves are bigger. What if we open the entrance a little bit earlier? It incorporates infrastructure management, which could include dams that overtop, dam release management, and other stormwater assets. Scenarios typically take 10 to 15 seconds to run and are optimized for speed. To assist in the visualization of the scenario modeling results, an extent investigator is provided to link the results from scenario modeling flood extents surrounding the lagoon. Some of the outputs from the MHLFIT system include predicted flood extent mapping, which is linked to model results, and an asset risk management tool that links predictions to local assets to help identify whether the event will be an issue and where to deploy resources. The real-time modelling runs every 15 minutes, and the results trigger alarms if specific thresholds are met. These can include water levels, rates of rise, and various other calculations. The alarms and the alerting I spoke about are managed by a web-based alarm management system, which has been built with an escalation process. For example, Matt might get an alarm telling him the lagoon level is predicted to exceed the current managed berm height, and we should get someone to go down and have a look. If he does not respond within 2 minutes, it will then send an alarm to Galen. And then if he does not respond, it'll send an alarm to me and I'll have to go down and have a look. This sort of alerting can be used to inform resource management, not just for lagoon openings, but road closures and emergency management resourcing. We are looking at a number of technologies, including photogrammetry and real-time LiDAR, artificial intelligence for parameters such as rainfall losses, which is really important when you're predicting these sorts of systems. And we'll start to build in more of the Bureau of Meteorology products as they become available. We already include the ADFD and ocean water level predictions and wave predictions, but there are new products coming online all the time. We'll also further develop the automated prediction and messaging and linking to council workflows, resource allocation, and emergency management coordination. Thank you for listening, and I hope you found some parts interesting and informative.